The Fundamental Theorem of Calculus, Part 2. Mathematicians spent a lot of time working with the topic of derivatives, describing how functions change at any given instant. This is the first branch of calculus. They then sought a way to describe how those changes accumulate over time, leading them to discover the calculation for the area under a curve. This is known as integration, the second main branch of calculus. Finally, Leibniz and Newton discovered the connection between differentiation and integration, known as the fundamental theorem of calculus, an incredible contribution to the understanding of mathematics and the blending of the two branches to what is present-day calculus. The connection is the reason why definite integrals and antiderivatives, i.e. indefinite integrals, now use the same notation. The connection discovered between these two major concepts is so crucial to calculus that it is called the fundamental theorem of calculus. There are two parts to this theorem. Believe it or not, we are going to learn part 2 first because it will help us understand part 1. The second part of the fundamental theorem of calculus states, if f is continuous at every point on the closed interval a to b, and if capital F is the antiderivative of f on the same closed interval, then the integral from a to b of f of x dx is equal to capital F of b minus capital F of a. This theorem is extremely important. Recall the following about a definite integral. The limit as n approaches infinity of this sum is equal to the definite integral as from a to b of f of x dx. We now know that this same definite integral is equal to capital F of b minus capital F of a. Since both of these are equal to the same definite integral, we can set these two equal to each other and say that the limit of this sum as n goes to infinity is equal to capital F of b minus capital F of a.